Hey guys, Professor Calculus is here, and today in this video I got an integral for you that is only solvable with Feynman's trick of integration. So, how do we proceed? First of all, for Feynman's trick of integration we need a parameter, and this integral is already parameterized, and I can call my integral I of a, which is the integral from 0 to infinity of e to the negative ax minus e to the negative bx over x secant of px dx. And I can take the derivative of this integral with respect to a. This is going to be ddA of the integral from 0 to infinity of e to the negative ax minus e to the negative bx over x secant of px dx. And this ddA is gonna go inside, and my I prime of a is gonna be the integral from 0 to infinity of partial a of e to the negative ax minus e to the negative bx over x secant of px dx. Now, my I prime of a is the integral from 0 to infinity. If I take the derivative partially, this term here is a variable. Thus, I should apply this only on that one. Thus, it's going to be negative x e to the negative ax over x secant of px dx. These two are going to go away. My I prime of a is going to be the integral from 0 to infinity of negative e to the negative ax cosine of px dx. And now, integration by parts tells us that if I have an integral u dv, I can write it as uv minus v du, and we're going to utilize that definition for this. I'm going to let this be equal to u and this dv. If u is negative e to the negative ax, my du is a e to the negative ax dx. If my dv is cosine px dx, my v is sine of px over p, and this is my table of the integration by parts. Now I'm gonna apply this to this integral here. So I prime of a is I prime of a is negative e to the negative ax over p sine p as over x. Sorry, just gonna write it again. Negative e to the negative ax sine px over p, the limit from 0 to infinity, minus the integral from 0 to infinity of a e to the negative ax sine of px over p dx. This limit goes down to 0. You can go ahead and verify it. Thus, my I prime of a equals negative a over p, the integral from 0 to infinity of e to the negative ax sine of px dx. The integral here, I'm gonna use the u substitution again. The integration report. I'm gonna say du equals e to the negative ax, and du is negative a e to the negative ax dx. I'm gonna say dv equals sine of px dx, and v is negative cosine of px over p. Now, if I do the integration, I prime of a is going to be negative a over p e to the negative ax times negative cosine of px over p, the limit from 0 to infinity, minus negative ae to the negative ax, negative cosine of px over p dx. And my I prime of a is going to be negative a over p of this limit here is going to go down to it's going to go down if you calculate it, and the first is going to be 0, and the next one, well, let me do it for you here to show it better. The limit of e to the negative ax cosine of px over p, the integral from 0 to infinity, is negative e to the negative infinity. The other terms are not important because this alone is going to go down to 0, minus negative e to the 0 cosine of 0 over p, which is negative 1 over p, which is 1 over p. So my I prime of a is negative a over p 1 over p plus a over p, the integral from 0 to infinity of negative e to the negative ax cosine of px dx. I prime of a is negative a over p 1 over p plus a over p I prime of a, and I prime of a is going to be negative a over p squared minus a squared over p squared I prime of a, and I'm going to have I prime of a plus a squared over p squared I prime of a equals negative a over b squared. And my I prime of a, if I factor it, it's going to be 1 plus a squared over p squared is negative a over b squared. P squared plus a squared over p squared is negative a over b squared. Thus I prime of a of mine is negative a over b squared times oh sorry, it is supposed to be p squared. I don't know why did I do that one. Yeah, but the I prime of a is supposed to be negative a over p squared times p squared over p squared plus a squared. It's going to go away. I prime of a is going to be negative a over p squared plus a squared. And if I integrate this thing here, you can use a u substitution here and see that I of a is negative ln of p squared plus a squared, sorry, negative half of ln of p squared plus a squared plus c, some constant of integration. Now, how should we find this constant? If I have the integral from 0 to infinity of e to the negative ax minus e to the negative bx over x secant px dx equals to negative half ln of p squared plus a squared plus c. So, I think I made another error here. No, that's fine. So, if I let a be equal to b, this is going to go down to 0 because it's going to be e to the negative ax into the negative bx minus e to the negative bx, which is 0. And my c is going to become half ln, if you substitute b for a here, p squared plus b squared. And my I of a is half ln of a squared plus p squared minus ln of t squared plus b squared. And thus the integral as a whole, I can use the power of logarithms, which is equal to half ln of a squared plus p squared over p squared plus b squared. And that is the final form of my integral. Hope you enjoyed this video. Please like and subscribe and share my videos. If you have any questions, let me know in the comments, and I'll see you next video.